Today we are going to solve the problem number 54201 matrix of LeetCode. So the problem is quite straightforward. We are given a matrix m plus n, and what we need to find is the distance of the nearest zero from each cell. So what it means is, suppose if we have this matrix, example 1. So let's see this. So what will be the nearest 0 for a cell which has already a value 0? Obviously it will be 0 only. Similarly for this, but for this one where it's 1, the distance will be 1, because if we check to the left or to the right or to the up or to the bottom, we can find the distance easily to be equal to 1. Now let's look in the example 2. This matrix, we have value 0 0 0 1 0 1 1 and 1. So how will the distance matrix look like? So original matrix, and here we have distance matrix. So obviously the distance for this 0 will be 0 only. So we can put just simple zeros to all the cells which have value zeros. Now let's observe this one. If we move to the right, there is one distance to the top, same to the left. So we can find the 0 at one distance from this cell and this cell. So, this distance will be 1. Same for this one, this distance will be 1, and for this one. But for this one, if we go up, we go right, or we go left, we can't go obviously to the bottom because there is no cell over there. So the distance will not be 1. Here the distance will be 1 2 if you go this way, 1 2 if you go this way, or 1 2 if you go this way to reach the 0 cell. The distance here will be 2. So this is how our output matrix will look like. So how can we solve this problem? Let's see to the constraints. Here we are given m and n, and the values of m and n, m cross n, can go up to 10 to the power 4. And also there is given that there is at least one 0 in the matrix, because if there is no 0 given, so the distance will be infinite, or you can say there is no distance possible. So that's why it's given in the constraint that if there is at least one 0, and all the values are either 0 or 1. So if we try our brute force solution, so what could be the brute force solution? For every cell, we go to its right, left, right, up, down, bottom, and simply find the first occurrence of a 0, like we used to do the BFS. We, we first take the distances which have one distance, all the cells with one distance. Then we move to the cells with two distance, like this, this, and this. So this will be of second radius, then to the third distance. So this will be this all will come in 3 degrees. So for each cell we have to traverse the whole matrix again in the brute force. So our time complexity will be m cross n square, because there are m cross n elements in all, and we have to traverse all elements for every cell. So m cross n into m cross n square, which makes us 10 to the power 8. But this might not run because it's equal to 10 to the power 8. and we need less than 10 to the power 8 operations. So what can be the efficient approach, or we can say optimal approach to solve this problem? So as you can observe, what we are doing in the brute force is we are taking a cell and taking a cell and looking out for zeros in it. So same thing we can do. We know one thing, that every cell with value 0 has distance 0. For example, this has distance 0, this has distance 0. So we can take this out. So we know for sure that these cells will have distance 0. So we'll add them, we'll use a queue data structure. So many of you might be thinking that we might use a priority queue like in Dijkstra's algorithm, but there is no need for using that, as we'll see later in the problem. So we will first add the indexes of those cells which have 0 values in them. So for example 0 comma 0. So 0 comma 0 will come first, then 0 comma 1, 0 comma 2, similarly 1 comma 0, and then 1 comma 2, because rest of them are already 1. So we need to pop one element from this queue and process its neighbors. So that means these all have distance 1. We already know this thing. So we will move one step in each direction, and if these cells are not visited, we will visit them and make their distance 1 plus to the distance of the already present element in the queue. So let's so for this we will make a result matrix. So we can take another example where this might be 0, 0, 1, 1, 1, 1, 1. So it might get easier to solve. So in this example, so this is our example. We will first add the elements with geo distance in our queue. So 0 comma 0 is there, and 0 comma 1 is there. This is our original matrix, and we will also make a resultant matrix. So this is our resultant matrix. Yes. Initially, we will take something -1, because we also need to make sure that we don't visit the matrix elements twice. As so, we'll initialize all the values with -1. When we find the element in the original matrix is 0, we will replace these with value 0. This will become 0. This will become 0. Now we will take elements out from this queue. So first this will come out, and we will process its neighbors. So this is a neighbor, but it's already visited because it's non-zero value. This neighbor, these neighbors don't exist, so we don't need to. We need a condition to check if the neighbor is valid or it's already not visited. If it's a valid cell and it's not visited, then only we need to process them. So we here in the cell 1 comma 0 will update its value. The distance here was 0, so we'll add 1 to the value, and this will become 1. Take different color. This will become 1. Next, so this will become 1, and we will add it to the queue because we need to process its neighbors now. So this has already come out of the queue. We will add 1 comma 0 to the back of the queue. Now we'll take out this and process its neighbors. So its neighbors is this and this. So the distance will become 1 for this and similarly 1 for this also. And we'll add these values in the queue. 1 comma 2 and 0, it's 0 comma 2 sorry, and 1 comma 1. So these values will be added. Similarly, we will process these elements by taking out and adding their neighbors. So this value will become 2, this will become 2, its neighbor of this, this will become 2, so and this value will become 3. So the oriented matrix will look like this: 0 0 1 1 1 2 2 2 and 3. So this is our resultant matrix. So what we need to do is make a simple queue, make a matrix to store the results, take out the elements one by one from the queue and process them, process their neighbors, and update the values in the resultant. So let's see how we code this. Okay, so let's now move to the coding part. We need our resultant matrix, so we'll make a vector. First, let's take the size of the matrix. We are storing the values in N and M. Now we need to take the matrix. It will be of size n cross m. So n, and this will contain the vector of integer types. And its initial value will be 0 because we need to keep track of all the visited elements. So if it's -1, it means it's not visited or not processed. So now, as we have initialized our real-time matrix, we need to process all the matrices with values 0. So we will simply traverse the loop. If matrix at I and jth place is equal to 0, what we need to do, we need to make the result at this cell equal to 0. Also, we need a queue, so we'll make a queue here. We need two places, so we'll make pair of queues for indexes x and y. Now we simply need to add them inside our queue. Till now, here what we have done is we have made a simple matrix of size n cross n. We have taken a queue. We have added all the values with all the cells with value 0 to our queue and also updated their values in our resultant matrix. Now what we need to do is process them one by one. So while our queue is not empty, What we need to do is pick out the element. So we are using auto here, row, column, q dot. This will take the front element of the queue. You also need to pop the element. So that's within our process. Now we have got hold of the first element of the top, front element of the queue. We need to process its neighbors. For that we make two simple matrices dx. And now we need to process its neighbors. We got hold of this cell. So we will, there can be four neighbors only, left, right, top and bottom. So we'll, I will get the new row equals row plus tx at I, new column equals column plus tx. First we need to check if this new row and new column element is a valid or not visited. So if new row is less than 0 or new row is less than column is less than 0. So an index cannot be negative, we all know, so this will make it invalid. Or new row is greater than equal to n, or new column is greater than equal to n. Also it cannot be exceed n and n, so this will also make it invalid. Also need to check if resultant at new row and new column is not equal to -1. If it's not equal to -1, it means it has already been processed and we need not to further process it. So if these any of these cases are true, we need to continue. And if it's a valid index and not visited, what we need to do is update our rows. So the resultant at this cell will be the 1 plus resultant at row and column. So this will be new row, new column. Now we need to add this element in the queue to process the further to process its neighbors. Dot this new column, and then this neighbor will be processed and so on. So this will complete. So we need to return the related matrix. So let's see what we have done. We have first initialized a real-time vector with values -1. Then we have taken a queue. Then we have added all the values with zeros, all the cells with value 0 in them in the queue. Next we have made these two arrays to get the indexes of the neighbors. Next we are taking out the elements from the front of the queue until the queue becomes empty. Once we take out the front of the queue, we pop it and we process its neighbors. We get the indexes of the neighbors and check if it's a valid index and not visited earlier. Then if it is a valid index and not visited earlier, we update its value and add it into the queue to process further. And finally we are returning the resultant. Let's check if the so sample test case got accepted. Let's try to submit. It's submitting. Fine. So thank you. See you in the next video.